this working? Yes. Okay. Let's see. So we're going to explore. We're going to go to here, here. And then source, assembler, main. And then VSP, explore, tileset defs. Okay. So what I have right here is the assembly source code for a program that basically all it does is it does a full tile set print of every character in its known tile set, and it puts them out to address 0x8000, and then immediately after that it does hello world with an exclamation mark. And that tile set is defined right here at the tile set origin. So the tile set origin just it's like a list, in the sense that you give it this full list of all of these different tile sets, and then here I'm defining at 21 or 0x2100 the start point that I'm putting them into, and then I'm going from the label at the top. So this tileset origin down to the bottom tileset end, and that's the address of that is at the far ends of this tileset list. That's going to be in the memory file of the generated assembly code. Okay, so and then when I run it, it will do this. So make clean run. Oh, I'm in the wrong directory. And as we can see, here is hello world at the very beginning, and then here's all of the different characters. So never mind. So so if you look at closely, we have an exclamation mark and then a number of different characters, all the way up to like a copyright symbol, and then some other character-defined files. And then so they're essentially written out to a grid that has that keeps these values of what are essentially binary bitmap values of like 1 pixel is off, 1 pixel is on here. So these are all defined, these are all a picture that are created off the bat by this code. So if we open this up, emulator, This is an emulator. And we have defined a number of constants, such as the foreground color and the background color. And then we have a tile set size, tile height and a tile width, and then a grid size. So we have a tile set which is defining which is an array that has every single type of character that can be displayed, and then for each of those they're a height of 8 by 8. So this is the tile height, and each of those entries is 1 byte long and 1 byte high, essentially. So it's like a long. And then we have a display grid where in the display grid, that's what is. So if we run it here, granted this is building it again. So the display grid has a grid size of 0x10 by 0x10, which is essentially 256. So and so it's listing all of these out. Now, if what I wanted to do was I wanted to change some of that tile set, what I could do in addition is I could I can go to this assembler and I can go to this tile set def, and then let's say I want to add just another tile. This will be at the very end. So let's just do something like a checker grid pattern. So 1 0 1 0 1 0 1 0, and then below that we do another checker grid. There we go. So, and then I believe that's 1 2 3 4 5 6 7 8. Alright. Alright, so if we do that, and then we run it again, so we have that. So that right now is a blank. If we run it again, we have that nice checker grid pattern right there. Or if instead of that we wanted to do, or in addition to that, we wanted to do something like a one of those like patterns where instead, so we have it where everything in this box right here let's just do that, and then keep on getting my Vim commands wrong. And then alright. And then so this will just have like a an alternating on and off pattern that will surround the block, the tile. Now I really should fix this make file to not have to recreate it all the time. And there we go. It's just sort of like a highlighted outline. And then, so we take this, we can do something in addition to that. We could do, instead of like that, we could have it alternate the opposite way. And there we go. And then we could also do something where instead we just have the entirety of the border around this tile. Okay, that didn't work. Oh well. Oh well. Now I guess, yeah, that'll work better. And there we go. And now we can do a make run here. And when we see it, you'll notice that the pattern is a little bit different between those two, and then there's a solid pattern around that one. And the reason why this is working is that we've defined the beginning and the end, and the code. Let's see. Oh, I don't have that open yet. Or I closed it. So it starts at DE, or it starts at 2100 in hex, which corresponds to the very beginning of the tileset character definition, where the very beginning of it is 2000. But I'm not starting at the very beginning. I'm actually starting. So if I go there, no. There we go. Get my Vim commands straight. So I'm starting at this, which is space, and then this, which is the exclamation mark. Which, if you look right here, that's where the exclamation mark starts, at the very beginning. I could, if I wanted to, if I wanted to start at the very beginning and include the full tile set from the very, very beginning, I would define this tile set, or I'd add all of the tiles prior to this one, and then I'd set the initial value. I'd set this initial value to be 0x2000. Yeah, and yes, okay. And when the tile set gets fully printed, it counts this as, well, it's doing a string, because it's putting the origin of full tile set print as though it's a string, and it's doing just like a standard string print. So 0 is not represented here. Yeah. So these are wind up just being spaces, and then pretty much everything after 1, 2, I don't know exactly what it is going to be just average stuff. And then this hello world message, which conveniently maps on to all of the ASCII letters, as well as this exclamation mark. And I believe that the only thing that is really off is this pound sign, because this is the I actually cribbed this from the ZX Spectrum tile set. So there we go.